Okay, we're going to do number 4 on the practice exam here. You can see it's a question about differential equations. And it better be what's called a separable differential equation, because those are the only kinds that we really know how to solve. Okay, and you're also given this fact that when you plug in 1, remember we're thinking of y. Y is some secret function of x. This is the whole idea of a differential equation, is there's some secret function of y is some secret function of x, and this relationship is true with that unknown function y. So what we have to do is we have to find the y, find the function that makes this relationship true. And when we find it, there's going to be a whole family of solutions, and they're going to be related to each other by the value of some constants that come up. And with this little fact here, the initial value, you can call it, they give you a point. You can call it the initial value or whatever. This is going to let us find some of the constants. All right, so remember the idea with separable differential equation is that somehow we're going to be able to rewrite this stuff as, hopefully, some function of y, let's just call it f of y, times some function of x. Alright, so this is why they call it separable, because on the right hand side you have separated things into a product, or sorry, just a function of y times a function of x. So when you do this, you can kind of cross multiply here, and then you get two integrals that you can solve. So I'll do it. What happens here? You're going to be trying to solve. You have 1 over f of y. Dy is equal to dx times g of x. And then if these things are equal, then their integrals are equal. And so, here, assuming that you can do this, you're going to get some function of y, and then you can mess around and hopefully find out what y actually is, actually completely solve for it. So that's the plan. That's how you do separable differential equations. So here we go with this particular equation. The first thing we want to do, I guess, is solve for y prime. So let's just try to get y prime by itself. So I have xy prime is equal to y squared minus y, and then I can just divide through by this x. Okay, so I'm just going to divide through by x here, and then it goes over here, and so you have this. Alright. So I have separated things into a function of y times a function of x. So if you don't believe me, just think of it like this. Think of it as y squared minus y times 1 over x. Okay, so here's your function of x, and here's your function of y. And where is dy dx? Well, it's right here. So let's write it like that. So dy dx is the same thing as y prime, and it's equal to this function of y squared minus y, times this function of x, 1 over x. Okay, so we do the trick that lets you solve separable equations. You multiply, kind of cross multiply by dx, and move the y stuff over here. So I've got dy over y squared minus y is equal to dx over x. Okay, and if these things are equal, then their sums are equal. Alright, excellent. So now all I have to do is solve these two equations. This one is easy, right? This is just natural log of the absolute value of x plus c for some constant c. And this one is a kind of challenge. So for the y integral here, we need to do really easy partial fractions. So the same thing as dy over y times y minus 1, right? And so the idea with partial fractions is that there's some way to break that up. So we want to try to think of some way to break up y times y minus 1 into this sum, a over y plus b over y minus 1. Okay, alright, where a and b are numbers. So if you can achieve this, then this integral becomes this, which is just natural log, the antiderivative is just a times natural log of y, and then the integral splits over the sum, so you can do the integral of b over this, which is just basically b times the natural log of y minus 1. So, alright, so that's the plan. That will give us, that gives us a trajectory or whatever. It gives us a way to get to the answer. So what are A and B? So clear here by y times y minus 1, and you get 1 is equal to, now the y hits this y and dies, and you get a times y minus 1, and the y minus 1 hits this y minus 1 and dies, and you get plus b times y. Okay, and now we have this equation that's going to let us solve for a and b. Alright, so what I want to do is pick the value that makes one of them disappear, right? So let's just say that y is equal to 1. Then what happens? Then I've got 1 minus 1 and y and a gets killed. And when a is 0, I get this equation 1 is equal to 0 plus b, and this tells me that b is equal to 1. So I'll make a little box around that. Okay, so b is 1. And what happens if, now I want to kill the other thing, I want to kill b, I can do that by making y 0. So this tells me that 1 is equal to, now when I plug 0 in here, I get negative a, alright? So a is equal to negative 1. Alright, and I think this one is simple enough that you could have just figured this out. But anyway, now we know that instead of doing this, we can solve negative 1 over y dy plus 1 over y minus 1 dy. Okay, so we'll just do these one at a time. So what is that? You can take the minus sign out, then you have the integral of 1 over y. That's just going to be natural log of the absolute value of y, right? Okay, and what about this one? You could do u substitution if you're feeling kind of shaky or something, but come on, it's just natural log of y minus 1. Okay, so substitution would be, it's not really necessary here because the derivative of the stuff in the denominator is 1. So whenever that's true, the answer is just kind of what you would hope it is. Alright, so I can clean this up a little bit. Remember, by the properties of logs, this is the same thing as, first of all, it's natural log of y minus 1 minus natural log of y. And then when you have a difference of logs, the laws of logs let you write it as a quotient. So this is y minus 1 over y. Okay. Alright, so remember why we're doing this. So up here we have this thing, okay? And they're equal. So they were always equal. So let's put x back in the mix. And remember, what we want to do, if we can, is solve for y. So maybe I can cut this. Running out of space here, so let me push all this stuff down. Alright, and this is what we're trying to do. So in this equation, you can get inside the natural logs by applying e everywhere, by applying the exponential function. So apply e to both sides. Then on the left-hand side, you get y minus 1 over y. Okay, easy enough. And on the other side, you get, well, let's do it like this. So I'll do it the long way. So you get e to the natural log of x plus c. This is the same thing as, e to the natural log of x times e to the c, because that's just the way exponents work. Now I'm going to rename this a new constant, which I'm going to denote by the letter k. So this is just a new constant. It's just going to make the notation simpler if I start calling it something else. And look what happens here. This is a composition of two inverse functions, right? So e and natural log combine to cancel each other. So what I have here is k times the absolute value of x. Right, so just to recap, I have the absolute value of y minus 1 over y is equal to k times the absolute value of x. Okay. Alright, so we could get rid of the absolute value signs by putting in some plus minuses. But since, we are dealing with a constant here, let's just be lazy and just take the absolute value signs away. And the idea is that before we did that, k had to be positive, right? Because e only hits positive numbers. But when we take the absolute value signs away, we say that this is equal to plus or minus such, and so now k is just a non-zero number, right? So I'm down to this. Now this is what I have to solve. And it's kind of tough, right? It just keeps going on and on. Now I have two y's. What am I going to do about that? Well, just split apart this fraction. You get y over y minus 1 over y is equal to kx. Okay, and y over y, of course, is just 1, right? So this is the same thing as 1 over y is equal to kx minus 1. Now take the reciprocal of both sides, and you get y is equal to minus 1 over kx minus 1. And thank God, it's over. This is the answer. This is y, the secret function. And we can even do a little bit better than this, because we have this k still hanging around, this mysterious constant k. But this fact lets us even get rid of k. So let's see how that works. So know that when we plug in 1, negative 1 is supposed to come out. So let's do that. So what is y of 1? Okay, so what happens when you plug 1 for x in here? You get negative 1 over k minus 1. And what is this supposed to be again? This is supposed to be negative 1, right? Alright, so we'll just set it equal to negative 1 and then solve for k. So this is saying that 1 over k minus 1 is equal to 1. So I cancel the negatives. And now take the reciprocal of both sides, and you get k minus 1 is equal to, the reciprocal of 1 is just 1. So k is equal to 2. Alright, what could be more satisfying than that? I think we've done some very good work in this problem. So minus 1 over 2x minus 1 is the answer. Okay, so we got the family of solutions to the differential equation, and then this initial condition let us pick the one that we wanted for the answer. And so this is it. So maybe just for fun, could actually put it in the answer box. There's the answer. Don't know what happened exactly just then. And alright, so here it is. How do you like me now? Great, so that's it.